So tomorrow, guys, we are doing some review. And today is really your last time to work with this content for chapter 2. Okay? Because what we move on to starting Thursday is we are looking at how these elements start interacting with one another. I'm not sure that that is actually plugged in for you. Okay, let's take some time. Make sure that before you go to sleep, your Chromebook is plugged in. It's really important to always have a charged Chromebook. Okay. Get that done. So this is the last day where we're looking at just the types of elements in general and how they fit on a periodic table. What can people tell me about metals? Harmony?
Luster. It has
Okay, what does luster mean?
shiny, reflective.
So has luster, which what that really kind of means for us is shiny. Now, yes, is it luster R-E or E-R?
ER.
E-R? Sorry guys, I switch back and forth between different spelling, and I'm not really sure which one it's supposed to be now. I'm even going to look it up in the textbook just to be sure. Because different parts of the world actually spell that slightly differently. Yeah, it is ER, you're right. Okay? In Canada, the Canadian or the British spelling is RE. That's why I'm like, sometimes I can't remember which one's which. Okay, has luster. We need to use this word. That's the specific science word. Like if you ask me during the test, oh, what does luster mean? Sorry, can't help. Okay, that's why I'm trying to give you other words to help you remember what that vocabulary word is long before then. What's another property of metals? I need someone other than Harmony. She's doing great. Okay, how about I pick on like Christian? What's another property of a metal? Like, I will tell everyone, I pick on everyone, I try to make sure that everyone has a chance to participate. So volunteer early so I don't like ask you one of the hard ones, right? So Christian Hodges.
I'm looking for my table because I had it on.
And none of this is sticking yet? Like this is the kind of stuff that I'm expecting to stick. Just warning you, that's just something I expect to stick. Jaden? It's going to be solid. 99% of the time, that's true. Do you know which one is an exception to being solid? Mercury. Mercury is a metal, but at room temperature. They used to use it in thermometers because it was a nice metal, but they found out that that was kind of problematic because we literally can absorb mercury too easily. And it stays in our system. Like it can become poisonous to us. Okay? David, give me another. Conductive. Now, can anyone actually give me some more information on this conductivity, Christian? No, I'm asking about this, it being conductive, like, conducting what? Sydney?
It conducts well to electric current.
Okay. Conducts electricity. And it conducts heat. Okay. Now who said ductile?
Me.
What does that mean? Like that's another one of those that I'm like, okay, like conduct, for some reason, like that's part of our regular everyday language. Ductile? No. That's a weird science thing. What does being ductile mean, Denia?
Stretch?
Yeah, I can stretch it out.
It's a long wire. Oh, it's the box.
Okay, another word is to stretch. Well, what was the other one that was like similar, but instead of like pulling it out?
Malleable.
Malleable. Malleable. Now, if it was malleable, what did that mean?
It can be pressed. Flat.
I can press it, I can squish it.
But it would still be the same kind of material.
So this is kind of like the ductile is like being able to pull it. Being malleable is kind of like being able to push it and squish it.
I feel like the same thing since stretching it is kind of like flexible.
No, like ductile means I can pull it into long strings. The malleable, I'm going to, rather than pulling it, I'm going to like be pressing and pushing and trying to, like I could squeeze it into a ball, I could pound it out into a sheet, but it's a very different force. Like, is this force the same as this force?
No.
No. Okay? Anything else about metals? Do we know anything else?
No.
The majority of periodic tables.
Ah,
Oh, yeah.
this is most of, and I'm just going to say PT rather than the whole periodic table. Is that okay? Most of the PT, most of the periodic table.
More than 50%.
There was like what, 91 elements?
Yeah. I'd say it's.
There's like 118 on the current periodic table. 118. 91 of the 118 are metals.
That's like approximately 75%.
Let's actually do the math here. Okay, 91 divided by 118, 77.1%.
I was low.
Okay, anything else that you can tell me about metals?
They're shiny.
We have the shiny.
Oh, less.
We have that they're mostly solid except for mercury.
They're not also.
Now, are they always solid?
No.
When are they not solid?
At high temperature.
Okay, so if I increase their temperature, I can melt them. And that's how we make different alloys or mixtures of metals. I can have liquid metal. Why do they say they're solid?
Because
When they're at a room temperature, they start to harden.
Oh, whenever they give us this information, it's always at room temperature. Because we need a standard. This is kind of like a control variable in a way. Like we need to make the same comparison. And so because we need this frame of reference, you know, we don't want to compare different elements at different temperatures. It would be hard to make a comparison then. So we're saying, hey, if we're at room temperature, which is a normal temperature for us all to like do our daily life in, this is the form it's going to take.
So I have a question. So, not two metals, and you mix them together. Would they form a different type of metal? Or
Yes.
would they kind of be like a mix?
Well, okay. So Bella has a great question. And some of you guys, I'm not sure what all you're doing. Hopefully you're taking this down. Okay. I get concerned whenever I see a lot of stuff where I'm not even sure that you're like on what we're on. Okay, and this is really important, especially when you have another test, like in 2 days. Okay, Wednesday. What? No. Did you have a test last week? No.
I thought we took a.
Yeah,
I was in
that
was a quiz.
Okay. That wasn't even last.
That was the week before. What?
Okay. Hey guys, we're in week 7 of school. You've had 1 test and 1 lab so far. I don't think that's like over the top.
Yeah, we had a quiz. Last week.
Okay. At any rate, it's not a test. Your chapter 2 test is on Wednesday. But Bella had a really great question. She says, hey, if you melt 2 of these metals and you combine those 2 elements together, what do you get? She's like, do you get a new metal? Do I get a mixture of metals? Like, what is that? Okay. Remember I introduced that word alloy. Okay. Now, an alloy is a mixture of metals that will act as a new metal. Now, it doesn't mean that it's a new element. Okay. That particular metal is made up of 2 of the elements, or maybe more than 2 of the elements mixed together. Okay, and really that's our next chapter, is as we look at how to combine different elements on the periodic table, what new materials do I get? Does that make sense? Right now, all we know is what's on the periodic table, and that each of those types of atoms are unique and can be organized in such a way, but we haven't talked about how any of them really interact overall. Okay, so the next thing is really that interaction. Okay, so 2 or more elements can combine. There are ways that those things combine. Okay, and it depends on if we're talking 2 metals, or if we're talking 2 nonmetals, or a metal and a nonmetal. They all react differently, but it's going to follow similar patterns depending on the types of things that are interacting with one another. Okay, so that's next chapter. We're not worried about that quite yet, but it was a really great question. If we combine different elements, we don't get a new element, but we will get a new material. Okay, which may be a compound, an alloy, or something else. What do we know about nonmetals? Jack, can you give me something that's true about nonmetals?
They're brittle.
They're brittle.
I thought that was for metalloids.
I do think that is true for metalloids too. Just because it's true for one doesn't mean it's not true for another. And there's kind of reasons why metalloids might share some traits of nonmetals, or share the traits of metals, because they're what?
The mixture of both.
Well, they're not a mixture of both, but we're going to call these metal-like. They're kind of metal, kind of not.
They're all blind.
Okay? They can, depending on what they're trying to interact with, they will take on different, like, sometimes it seems like they're acting more like a metal, sometimes they're acting more like a non-metal. They're in between. Okay, but they are their own selves. Okay, what does brittle mean? Do we remember? Is that like common vocabulary for us, or is that like a science vocabulary?
It was on the video.
Hmm? It was on the video. Well, that doesn't necessarily mean it's science vocabulary. Like we tend to think of conductive as a little bit more science vocabulary, but ductile and malleable, I don't use that in my everyday life. Not quite the same. Like, I probably do, but I'm not sure that you did. Is brittle something that you would use to describe something?
Yes.
Yeah.
Okay, well, what does that mean to you?
Easy to break.
Easy to break, okay.
It's not very stable.
Not very stable? Okay. What other non-metal properties do we know? Jack?
Like some of them are gaseous.
Ooh. So we could say brittle or gaseous. And that was like, it takes the form of a gas, and not that it has gas. Okay, David?
Not ductile.
Not ductile. That kind of comes with the brittle. But I'll write it anyways. Not ductile. Probably means not malleable either, huh? Bella, give me another.
That non-metal can mix with most of the elements.
Okay. So she says can mix with most elements. It's another thing that we know about non-metals. Sydney?
Doesn't it contain phosphorus?
Yeah, phosphorus is one of them, but that doesn't mean that all non-metals contain phosphorus. That's just one example. So we could maybe write some examples. Let's try that. So Sydney says phosphorus is an example of a non-metal. What's an example of a metal?
Metal.
Yeah, well, name a metal off the periodic table. Like what metals do you know? What?
Potassium?
Potassium? That's true. That's an alkali one. How about things like, do you know what AU is?
Yeah.
Gold.
What?
Gold.
Oh, really?
Fe is iron.
Gold is an element?
Gold is an element.
Oh, yeah.
Pure gold
Let's go.
is an element. Pure silver is an element.
Is diamond?
No, diamond. Diamond is actually, believe it or
Carbon.
not, a non-metal, and it's carbon.
Oh.
It's a specific arrangement of carbon.
Oh, really?
Carbon.
Oh.
C-A-R-B-O-N.
Wait,
Carbon.
what if we could make diamonds?
People actually have to some extent. You can actually artificially produce diamonds. Typically, a lot of those are also used within industry for different cutting tools, etc. But there is artificial diamonds, artificial gems that are made. What they do is they take the raw material and a lot of pressure, a lot of heat. Okay? If you think about the rock cycle and knowing about igneous, metamorphic, and sedimentary, they're taking something and they're trying to metamorphize that into a new form. They're not changing the composition, they're just changing how it's arranged together. Okay? What else can you tell me about nonmetals? Harmony? Semiconductive for nonmetals?
No.
Nonmetals don't
That's not
conduct.
always a-
Yeah, they don't.
Most don't conduct. They don't conduct well. But I will say there is a special case. You remember how back in 4th grade, how you made like a very simple circuit and you could like connect things up, like where you had a battery, a bulb, and a couple wires?
Would you like the circuit board game?
I missed it.
Yeah, kind of like that, I guess. Do you know that in place of one of those wires, you could actually use your pencil lead?
Really? What?
Well, carbon, specifically graphite is really what we use for pencil lead. It isn't lead, it is graphite, which is a specific arrangement of carbon that allows the pieces to slide across each other very easily. Okay? That arrangement is actually conductive. So even though it's carbon and it's a non-metal, it will conduct electricity. But most of this doesn't conduct very well. Okay, how about those metalloids? What do we know about metalloids? Texas?
They're semiconductors.
Semiconductive. That's probably like the most important thing about metalloids is hey, they are semiconductive. Does that mean that they're only like half conductive?
Yeah.
Like only half of them are? No. What does it mean to be a semiconductor? Bella?
That means you can't let electricity and heat flow smoothly.
Okay, so they don't always allow the flow of electricity. They don't always allow a flow of heat. And they use these in what? In electronics. They use these to build the chips, to build things that we can control the flow of electricity, that as soon as we turn the item on, we don't have this flow just rushing through like it's a raging river. They can control it using the semiconductive properties of these metalloids.
They're solids at room temperature.
Okay, so once again we have solids. These ones we said they were gaseous or they were brittle. If they're brittle, really that means that they're solids too, right, for the nonmetals. We also have, so this is solid, which is either, it's going to be a crystal, a crystalline structure, or gas. Is there any liquids? Few liquids. And metalloids are always solids at room temperature. So do you think we could identify these things? Maybe? Let's see what time we're at. Got a good amount of time. Okay. Ugh. Makes my hand a mess, huh? So let's take a look at this. Okay, here is what we're going to start looking at first. Now, does this material look at all familiar to us?
Yes.
Yes.
What do you think it is?
Lead.
Lead and graphite are two very, well, graphite is not an element. Lead is, but graphite is not the same element as, what forms graphite is not the same element as lead. Okay, lead is Pb. Graphite is made of carbon, which is C. So which one is this? Is this carbon? Is this Pb, lead?
Carbon.
Okay? So this is solid form. I can break it very easy.
Oh, I think
If I try to squish it, I get a powder. If I tried to pull it apart, I would still get, broken pieces and a powder.
Clearly lead.
You say it's clearly lead? So you're telling me that it's ductile, I can stretch it, it's malleable, I can squish it?
It's carbon. Okay, it's carbon.
It's non-metal.
It's a non-metal. This is graphite. This is kind of like what you'd use in art class.
Oh.
It's along the lines of charcoal. Okay? All of, charcoal, graphite, diamond, it is all part of the same family, just arranged a little bit differently.
Does lead look different from carbon, or do they?
Yes, they will look very different. Let's see. Well, I'm pretty sure I have some here. We'll see in the near future. Okay, how about this? Okay. What do we have here? It kind of reminds you of like something you'd use in a kitchen to clean a pot.
It looks like some kind of fabric. Like the string thing.
Now, honestly, the color kind of gives it away.
Copper?
It's, what you call it? Copper wire.
Well, this isn't really wire, but it is something where they pounded it flat and then they cut it into strips.
It's in like mango candy.
So this is copper.
Copper, that's it.
They pounded it flat and then cut it into little strips. So this is a little bit more like tinsel almost.
Wait.
Like that you put on a Christmas tree, and it's a little bit like your pot scrubber. If you weren't worried about not scratching a surface.
Are they like fibers?
Okay. Yeah, like I could pull out an individual fiber,
That's, okay.
and it looks kind of like this, and it could be flat at some point.
What if you stick it in an outlet? Would it conduct the...
Yes, this would definitely conduct.
So that's a butter.
Okay. This would copper is probably one of your best conductors, period. It conducts heat and electricity very, very well. Okay?
Then why don't we see it on our plates and pans?
You do see it on pans. It's just, it's expensive as compared to some of the other metals. Getting like copper cookware is actually fairly expensive. Like it is used, it's used commonly, but it doesn't mean it's in everyone's household. Or you might have some alloy that includes copper, but copper is also can be kind of soft. Okay, it's like some of these other metals. It can easily be malleable. It could easily dent. And so quite often what they'll do is they'll combine it with some other metals just to increase the structure, increase the rigidity so that it doesn't dent easily. And so sometimes you might have copper as part of the metal for your cookware, but you don't see the color because it's being combined with something else just to make it a little bit harder. And less easy to bend. Okay, so that's copper. So we know that that's a metal because of what? It's shiny.
Conductible.
It easily conducts.
Tile, metal.
Okay, how about? Why do you say it's sulfur?
Because it's yellow and powdery.
Oh, you think that
It does look like.
you think that that's the only possible yellow element?
No.
But it seems likely.
Yeah. Oh, that's the.
How about this one?
That looks like sulfur too.
That one's sulfur and that one's something else.
So what do you think it is? So once again, like if I try to press it, try to bend it. So here's what we have.
Can I smell it?
Could you smell it?
Just
smell.
I can't smell it. I
Can
don't
you
think
smell
it's
it?
sulfur.
Oh yeah, that's sulfur.
So some people think it's sulfur, some people don't think it is sulfur. It is sulfur. Okay, this is if I have a solid lump of it, but it's very brittle, not ductile, not malleable. It is a solid. It's not shiny. Now, like other people might think that the carbon we had might be a little shiny, but it's not shiny in the same way. Okay? Just like people think all metals are hard. Not all metals are hard as well.
So what's the yellow stuff?
What's the what?
The other yellow.
It's actually both the same thing. Okay. What do we have here? I have two different something. So what are these?
Like on the right in your right
Copper
hand
and
is copper.
silver.
Copper and silver?
Yeah, copper and
What
So
about iron?
The other one, yeah, the other one is the
copper and
Maybe silver and
One of them
iron.
is gotta be copper.
one of them's gotta be copper?
Yeah, one of them's copper.
So why do you say one of them's copper?
Because of the color.
Yeah, the color typically,
The
yeah.
hair, it's easy to define that though.
It could be. How about this one? Do we know?
Iron?
Silver. Iron and silver. Iron and silver. I think it's iron.
It is not iron. It is not silver. No one's guessed right yet.
Is it?
Are they both copper?
No,
Is it different color?
the orange one was copper. I'm trying to see if this one's open. There we go. I'm gonna compare a couple different ones for you right now. Maybe, are those the only strips I have? Might be. Okay, we're gonna compare 3 different ones.
Nickel.
Now, could you tell me the difference between these 3, just by looking or touching?
No. I could not tell.
They all look like a silvery. I gotta make sure I put this on here too. Okay, they all look kind of silvery, kind of gray. They all, yeah, I could definitely bend. So how can I tell the difference? What other stuff would I have to look at?
Is it?
Other characteristics? Well, they all kind of have luster. They're all shiny.
The metal one is gold.
What if we
Comparatively, but it still has luster. It's just not as shiny as the other 2.
wait?
And this one's shiny is.
Okay, so that might be,
It's probably nickel.
it might be a metal.
Now, so, what did you say?
It might be a metal one.
So it's possible she's saying, well, maybe there's something that's a metalloid. Metalloids could have luster too.
What if we try to conduct?
If I told you all 3 were metal, would you be surprised?
No.
No.
Okay?
Looks like a metal.
This one, everyone's quite used to. Except for they're used to it being a little bit thinner, and it comes in a roll, and you use it in your kitchen.
Is it on? It's on the
It's all on the
Is it?
periodic
Oh,
table.
silverware.
It's all on a periodic table.
Exactly.
What do you use in your kitchen that comes on a roll, and you'd have to pull it out, take a piece
Oh,
off?
oh, what?
Tin foil.
Foil. This is aluminum.
Oh.
This is aluminum. It's just this is thicker than what you'd put over your stuff in your kitchen. Okay? So this little strip is aluminum. This one here, this bar seems a little solider. It's just because it's bigger. I can still bend it. I can still stretch it out, have it be ductile. But this, okay, is iron.
Knew it. Iron.
Okay.
I-R-O-N. Now this one, no, I'll have to show you in the lab moving forward. But this one is very reactive to heat. Now, we're looking for more reactive. It's not going to be here. The more reactive metals are over here. Now, obviously, I'm not concerned about this reacting with the air or with water. Like, I could stick this in water, nothing's going to happen. It's going to be from this next group over. This one is magnesium. Okay?
What happens when
So, literally, what you see happen is the group 1 and group 2, they're really, really soft metals. Like, you can see how easy this is to bend. Okay? But they end up also being really reactive. And this is not as reactive as alkali metals. This is one of the alkaline earth metals. But this will definitely very strongly react to heat.
How do you talk about?
Like how? Like
We may not have specifically in class. Alkaline earth metals are group 2.
how will it react to heat? Like will it explode or no?
That's something we're going to explore in a future lab. I promise. Okay? Here is another element.
Sounds like lead.
You think it sounds like lead? I don't think it is. Okay, here's another metal. It kind of looks like little melted metal drops. Okay, almost like a candy, right? But it isn't. It's just chunks of this metal. This is zinc.
Oh, yes.
Zinc is actually something that is used a lot in your coins. Zinc is something like there's zinc oxide and different things that we use for like sunblock.
Can you sell like the pure metal for money?
Yeah, this is another, of course, all of these are elements. There are going to be pure element. And you can see it's really shiny. Okay, so this is really shiny, but it would be hard for me to bend with how thick each of these little drops are.
They look like a tiny little magnet.
Are they naturally like that small when you find them?
No, what they had to do in order for them to get these metals, you don't just see them like lying there in the street, okay? And they're not going to be out there in the country either. Typically what happens, and I know that is the case sometimes with gold. Like people go panning for gold where they try to dig it up, but they have to get it away from all the dirt and the rock, right? And so what they do is they will mine a particular area where they just take like the whole section of where they think the metal is part of, and they have to mix it with water and sift through just to get the right parts, because there's going to be a specific density. There's going to be a specific shininess. They have to get rid of the excess dirt and the excess rock just to get the bits that they need. And some of those bits may be large, some of them may be like little flecks. And they combine all of those findings together, as they submit it to, a larger company to say, hey, we want to sell this to you, or whatever, or, you want to take it someplace and you want to make something out of it. It's kind of like, going through a cereal box and just trying to pick out all the marshmallows. Does that make sense? Mm-hmm. They have to get that whole sample, and then they have to find methods to sort through that in order to just get the parts that they need, like just get the marshmallows out of the cereal and leave all the other stuff behind. That's just the way that God's created the world. That's not messed up. That's just the way it is. Okay. How about this one? Here's one you may not have seen before in this form. What does this look like?
Oh, that's wood?
I can see why you sort of thought that, because it's a little bit fibrous.
This does not look like a rock.
It looks like, maybe some chunks.
So it's either non-metal or another one.
So, why do you say non-metal or metalloid already?
Because
Based on what?
it's very brittle.
You think it's brittle?
Yeah.
Well, it could be. I don't think of that as being my main reason why I think that immediately.
It looks like paper.
Yeah, maybe it could look a little bit like balled up paper.
That's not.
In this form, at any rate.
Oh, no.
So it's not shiny.
Oh, it's like
Nothing shiny to me, and so I'm like, okay, well, if it's not shiny, it's a particular color. It looks like I can break that up even further, even with my hands. This is a little bit like chalk, similar, but this is calcium.
Can you draw with it?
I might be able to. I would have a hard time with the small chunks that I have. And it's going to be breaking apart consistently. The chalk that we use typically has been, compressed and formed specifically to be chalk. And so it's going to be having some other elements other than just like calcium.
So,
You may.
what is calcium?
What is calcium? Calcium's calcium. It's an element on the periodic table.
Like,
It is
what
a
do we-
non-metal.
What do we
actually-
use it in?
Am I right on that? Sorry.
It's a metal.
It is a metal. Oh, calcium, this is where things can lead astray. This is a metal.
Is it reactive?
It's going to be reactive, yes.
It's made of powder.
But this is, well, it's not a powder, but this one is not shiny the way that we expected it to be. So some of these things are not always true, but they're true for most of that particular group. Okay, this one is the alkaline earth metal, similar to our magnesium. Remember that coil of magnesium and this white substance that I just showed you, they're part of the same family. Oh. You're like, how is that even possible?
What family?
All part of alkaline earth metals. They're group 2. Group 2. Okay. I think that's the majority. Oh, no, I haven't shown you that one. And that one. I do want to show you those before we head out today. It's really hard when you can't spread out the way that you normally would for some of these things. Remember that I also talked about, here, maybe what we need to do is compare these two. Because I just showed you calcium, right? And I'll get calcium back out for you. And you think that it looked very, very different from that other really soft magnesium that I showed you, right?
Right.
How about now?
Actually, we're kind of the same.
Do you see more similarities now?
Yes.
So in my right hand, I have magnesium. In my left hand, I have calcium. So the grayish one is the magnesium. So, you know, some of these, depending on what shape we give them as we refine them, make things look a little bit different. So these ones look a lot more similar now. But I wouldn't describe either of these as really being particularly shiny. I think the shininess comes with more how hard they are in a lot of cases. Okay? So 2 last ones that I want to show you. Hopefully we have just enough time. I was like, what are they? And no, you cannot eat these. These are not sprinkles. Not sprinkles. Okay. So 2 different kinds. One looks shiny, one does not. This one I will say is a lot lighter. Like this looks like it should be heavy and it's not heavy. This looks shiny, but it feels kind of like plastic in a way. And this is not shiny at all. Okay? In my right hand, the ones that look like little sprinkles, this is lead. This is kind of like lead shot, really fine lead shot. Okay, so this lead is a metal. This one's not a metal. This is not a metal. This is a metalloid. It is definitely very brittle. It will break apart very easily. That's why you see this being really angular, the way that it is. This is silicon.
Oh,
This is-
silicon.
Yeah, this is like Silicon Valley.
You can make. You should. That's in salt, right?
That's what?
Salt. salt's made out of?
No, salt is
I mean,
sodium and chlorine.
I mean sand.
Yes. Sand is composed of silicon
But that's
and carbon.
pure.
This is pure silicon. Now, one thing that wasn't noted, non-metals, that's really important. Building blocks of life. Carbon, oxygen, nitrogen, hydrogen, non-metals.
So non-metals are more important than metals.
Kind of. They're both important, but without these non-metals, we wouldn't exist. But the majority of the different elements that we find are metals. That tells you how rare life is compared to the rest of the universe. Okay?